Okay, in this example, I need to simplify the numerator and denominator and then cancel any terms I possibly can. For the numerator, it looks like since I have 7x cubed minus 9x squared minus 10, looks like I could at least factor out an x. So I'm going to do that first and see what happens. 9x minus 10 over, and then for the denominator, it looks like I could at least factor out a 2, x squared minus 5x plus 6. I can't cancel anything out for these, the greatest common factor for the numerator or denominator, but now I can at least work on the numerator more and see what I can do. So 7 is not a perfect square, and it's not the number 1. So it looks like I'm going to have to use AC method. I'm going to change colors and work on that and see what we get, and then I'll plug it back in. So 7x squared minus 9x minus 10 kind of looks like a 6, 10 there. What am I going to have to do? I'm going to have to use AC method. So that's going to be 7 times negative 10, which is negative 70. Now we have to come up with the factors of negative 70, which add to negative 9. And I don't have the factors of negative 70 memorized, so I have to kind of think about it. If I prime factorize negative 70, looks like I can use 2, 5, and 7. I have to think about which way is this going to work. I need it to multiply to negative 70 and add to negative 9. So definitely the two numbers I pick are going to have to be opposite sign, and I'm going to have to pick so they add to a negative number. I think negative 14 and positive 5 will work. If I multiply these, it does equal negative 70. If I add them, it equals negative 9. So I think I found that correct. So I have 7x squared minus 14x plus 5x minus 10. I can pick my pairs. So I'll pick the first two, last two, factor within those. So I factored out that must be 7x, and that leaves behind x minus 2, and plus I can factor out 5x minus 2, and look at that, those are the same, so we can factor those out. X minus 2, 7x plus 5. Okay, so I just found out what this should be up here. That's what that should be. Okay. Now let me clean this up, and then I'll replace that, and then we'll work on the bottom. So let me switch this up here. Okay. Get rid of all that, so we have some room to work. Okay. All right. So I'll leave that part there because we're going to need it in just a second. Switch my paintbrush. Okay. Now, what can we do with x squared minus 5x plus 6? Oh, maybe I'll change a different color so we know. X squared minus 5x plus 6. This is a leading coefficient of 1 problem, so we need to find the factors of 6, which add to negative 5. Okay, well, it's either going to be 2 and 3 or 6 and 1, but I need them to add to negative number and multiply to a positive number, so they're both going to have to be negative. I think negative 2, negative 3 will fit the bill. If you add these together, you get negative 5. If you multiply them together, you get positive 6. So this is what we want. So I believe that this term is going to have to be x minus 3, x minus 2, and we can see already that's what's going to cancel out. All right, let me get rid of that real quickly, and then we can finish this problem. It's a long problem, obviously. Oops. Okay. Switch back to white. Okay, so we discovered that we have x and x minus 3 x minus 2, x minus 2, 7x plus 5. And I bet you thought I was going to forget that 2, but I didn't. Haha. Okay, so let's cancel this x minus 2 right here. And that's it. That's the best we can do. So there it is. X minus 3, 2, 7x plus 5. And that's the final answer. So all that work just to cancel x minus 2. But there it is. We did it. Okay, let's go on to the next example. X cubed plus 2x squared minus x minus 2 and over x squared plus 5x plus 6. This numerator here, since this is 4 terms, always think about grouping if you see 4 terms. And since we do, that's what I want to do. So I'm going to group those up into pairs. So I have x cubed plus 2x squared. I'm going to factor out the negative sign, x plus 2. Why do I do that? Well, it's always a good measure to do that. If this middle term is negative, to factor it out. Another way to look at it is you want these signs to be the same if it's going to work. Okay, so I'll leave that for another step, but that looks like it's going well. For the denominator, it looks like we have a leading coefficient of 1 problem. So I have to find the factors of 6, which add to 5. We kind of did that in the previous problem. So it's either going to be 6 and negative 1 or 2 and 3. It's going to have to be 2 and 3 because they have to add. So x plus 2, x plus 3. Okay, and we can say already that we're going to end up canceling x plus 2, but let's see what happens. I can factor out an x squared here, which leaves behind x plus 2 minus x plus 2 over x plus 2, x plus 3. Again, we can see we're going to end up canceling that x plus 2. So I have x plus 2, factoring that out, x squared minus 1, and that is over x plus 2, x plus 3. Okay, so I can cancel the x plus 2 as we've been guessing. Now I do notice that this is a difference of squares, so I could break this up as x plus 1, x minus 1 over x plus 3, but it's not going to cancel, so we can answer in either way. You can leave it like this, or you can continue on and see if you can cancel it, but you're not going to cancel an x plus 3. So we're done with that example, okay? Looking forward, we have 3q squared minus 24q plus 48, and we have 9 minus 63 over 108, or plus 108. So are we able to factor out a 3 out of all of these terms? I believe we can. Yeah, so I'm going to do that and see what happens. If I take a 3 out, I get q squared minus 8q plus 16. And here, what can we take out? I think we can take out another 3. 108 divided by 3. Looks like we can take out another 3. So we have 3q squared minus 21q. Q 36. Okay, that looks better. But now I'm starting to worry, I could have taken out another 3. So it looks like I could have taken out 9. I'm sure many of you saw that. And I was a little paranoid. So it should have said 9q squared minus 7q plus 108 divided by 9 is 12. Okay, now that's looking a lot better. We can cancel this 3 and turn that 9 into a 3. And we can start factoring the top. It's a leading coefficient of 1 problem. Actually, it looks like it's a perfect square, doesn't it? Q squared minus 8q plus 16. That looks like it's q minus 4. Yeah, that would do it. So we have q minus 4 squared because 16 is perfect square. Finish my q there. And what can we do with this? I don't want to forget that 3. I have q squared minus 7q plus 12. Here I need to find the factors of 12, which add to 7. That's obviously 3 and 4. And if we make them both negative, that's going to work. So I have q minus 3, q minus 4, and that's what we're going to be able to cancel. So that's it. We have, for the final answer, q minus 4 for the numerator, and 3q minus 3. And that would be the final answer there. Okay. All right, what can we do for this problem here, this example? For the top, I don't think we can do anything. But for the bottom, it looks like we could do something. Q squared minus 9q plus 20. This looks like a leading coefficient of one problem, so I need to find the factors of 20, which add to negative 9. I think 4 and 5, and they both need to be negative for them to add to a negative number. So that might be it. 4 minus q, and then we have q minus 4, q minus 5. And look at that. These are almost the exact same thing. So I have 4 minus q, q minus 4. And that's kind of frustrating because they're almost the exact same thing, but they're not quite. And so this is kind of the first time we're going to see this trick. If I factor out a negative sign, then they are exactly the same thing. Okay, and that is probably a little confusing at first. So let's just make sure that that's true. I have 4 minus q. I claim that is the opposite of q minus 4. If I redistribute that, the q becomes negative and the 4 becomes positive. Okay, so how did I know to do that? Well, my goal is to cancel something. And I noticed that these are the same, except they're just the opposite. So I was able to factor it, and now they are the same. So I'm able to cancel those. Okay, well then what is the final answer? It's going to be negative 1 over q minus 5. Okay, so that would be the final answer. All right, hopefully that negative sign isn't throwing you off. If it is, let me know, and we can go over it again. Okay, have a good day.